Alright, hello and welcome to Lab 4. I'm trying a new font in these slides, and for some reason my tablet is not working right now, so sorry that what I write looks kind of funny. So let us begin with the first slide. So what you're going to be doing in this lab is making relations in code, okay? So I'm going to give you two examples of how you can model just a relation as a set of pairs and think about that inside a computer, okay? So let me give you a function. So here is example 1, and then over here I'll write example 2 maybe, okay? So here's an injective function, boop, and it's injective, which means it's one-to-one, and maybe it looks like this. Maybe you skip that one, but nobody else is doubling up. So yeah, just kind of leave that one out, and sadly it is all alone. So let's pretend, let's number these like this. 1, 2, 3, 4, 5, 6, 7. And so the way to represent this, I'll call this R1, relation 1, as a set of pairs, remember, is the first thing on the left side of the arrow, and the second thing's on the right side of the arrow. Okay? So we have the pair 1, 2. That's saying that 1 is related to 2 under this relation, and this happens to be a function relation. And then 3 is related to 6, and 5 is related to 7. Okay? So you can just have pairs of ints, and that is something you can put inside your C++ program. So you can say that your relation is nothing more than a set of pairs of ints. It's that beautiful. You can recreate this as this type. Okay? That's the beauty of it. So now let me give you a symmetric relation so we can work with that. I'll just do a few dots, maybe 6 of them. 1, 2, 3, 4, 5, 6. So 1's related to 2, 2's related to 5, and I don't know, 5 is related to 6. So in order for this to be symmetric, everybody needs to be going this way. Alright, so that is a symmetric relation. We can write this again as a set of pairs. It's a bit longer because we got 6 things now. 1's related to 2, and also 2 is related to 1 in both directions. That's what it means to be symmetric, right? Then 2 is related to 5, and 5 is related to 2. And then 5 and 6 are both related in both orders. 6 is related to 5. Okay, so that can be your set that you represent as a set of pairs in C++. It's not too bad, I hope. So now let me show you what you're going to be doing. Let's go to the write-up and look at the code that you're going to be writing. Okay, so there's a bunch of files. The only one that you're going to touch, just like last lab, just one file, is this relation.cpp. Okay, so that's what I want you to look at, and you're going to implement this relation class. Okay, everything that is related is a bunch of ints. All right, so if you see 2 things, A, B, in that set, that means that A is related to B in that order in the relation. Okay, so here are the files. Let's go to relation.h first. Here is the relation class, and down here we see the one field of the class. That is all the elements in the relation. It is, of course, a set of pairs. And because it's a header file, I have to say standard : all over the place, right? Okay, here is all the stuff that you're going to implement. I've given you the constructor, which takes the elements and like sets them. And it's your job to implement all of these other methods to see who's related to who. So is the relation relating x and y? Is that true? Is this in the relation or not? Should be not too bad to look up. Is related left and is related right. I will give you an example of that. It's just finding all the things that are related on one side or the other with another value. And then we have a bunch of Boolean valued functions, which you can think of as like predicates. So we're checking if the relation is a function. We're checking if the relation is injective, is symmetric, is transitive. Okay, you're going to check all of those things. And the key, because you're only storing the elements in the relation, you're not like storing the domains or targets or things like that, everything's very implicit, okay? the domain is implicit. For like the functions, the domain is implicitly 1, 3, and 5, okay? Because those are all you get to see when you go and look inside of the elements of the relation, okay? So you can just assume that everything is correct. This is your domain, okay? If you want to think about it that way. So really, if you're checking for injectivity, you should just be making sure that nobody is overlapping over here. You don't have to worry about the domain being covered. You can assume that it already is, okay? That is the idea. Yeah. And then also, of course, you need to make sure that nobody's like doing that. That is also important. Everybody's going somewhere and only one spot. Okay. So that, I think, covers how you're going to model things. Let me now give you examples with these relations. Let's try and copy this the best I can. And I'm going to erase all the stuff that's not really there, because this is not part of the relation. Neither are these numbers. Okay? The only stuff that you can assume is in the relation is the stuff that is in the pairs. Okay? So you can convert those to these diagrams, and then let me show you is related to left, is function, and is symmetric on some of these. All right? So, and then we'll talk about maybe how to do it. So let's pretend that somebody calls relation r dot is related to left of, I don't know, let's say this is r1 dot is related to left. Now that one's kind of boring. Let's do r2 is related to left. r2 dot is related to left should give back all the things. So read it this way. It finds all of the y on the left-hand side such that y is related to x on the right-hand side. So find all the blank such that blank is related to left by, let's say, I don't know, 5? How about that? So you're finding all the things that are, all the blanks that are x that are related to 5. Okay? So all the things where 5 is on the right and it's related to something. That's the idea. Okay, let me try and put this in bold. I'm sorry that my tablet's not very happy. So all you need to do to find all the things that are related to on the left by 5 is, well, look in this chart and find all the things with 5 on the right. Yeah? So it looks like the answers, the things that are related, are 2 and 6. You see that? And that's what you're going to give back. You're going to give back this set 2, 6, because you need to give back the set of all the numbers, all the elements of the relation, which we're assuming are just ints, that are related on the left by x, or 2x. Okay, so is related to right is very similar. Hopefully that makes sense. You're just going to iterate through all this stuff. Oops. You're going to iterate through all of your pairs to make sure if something is working or not. All right, so that's that one. How about is function? So definitely r1 dot is function should give back true. And why? Well, you have to make sure that everybody, all the relations, all the things, all the arrows coming out of each thing are only going to one place. So you can't have something like this. You need to make sure that's not happening. So you're going to have to look at these very carefully, see if they're going to multiple places. Maybe you can use is related to on some side. Hoo-hoo. And then I think that's probably almost it. Yeah, that's is function, definitely. Is injective, yeah. Is injective is where you also have to check to make sure it's everybody on the right is only being hit once, okay? This happens to be an injective function. Technically, I could do this, and it could be a function still, okay? That is the idea. I think I might have confused the word function with injective function a little bit before, so just notice that this is fine as a function, and if I get rid of this one, this is also fine as a function. It's just not injective anymore. Okay, so this is also injective, so I might as well write it is injective. And so when you implement this one, you should also be making sure that it is a function in the first place. Okay, and then of course it will not be a function for this one, because the same input is going out to two different places. That's as if you were doing something like that. That is not allowed. Maybe that's what I drew before, actually. Can't remember. So just keep that in mind. You have to find what you need to check. Okay, that's part of the lab. And then is symmetric. This is how you might go about that. You can iterate through everybody and be like, okay, if I see 1, 2, do I also have 2, 1 is the question. So r1.isSymmetric is going to be false. Because there's not also a 2, 1 in this relation. So you need to go through everybody and make sure that their opposites are there. So like R2, it totally has those opposites. That will give back true. Okay? So you just need to iterate through everybody and make sure that you see, once you see 1, 2, you better also find 2, 1. And you can probably use isRelated to figure that out. Yeah, it shouldn't be too bad. Probably the hardest one is transitive. Okay? You're going to check if the relation that you're given is transitive. And I wrote a nice little hint here for you for that. Probably the best thing to do, the best way to go forward, is to write a doubly nested loop. Okay, so you have you're trying all the pairs of pairs, I guess. So you'll have one pair that is saying that A and B are related, and then you'll have another pair saying perhaps that B and C are related. And if they do match up right there, if they match up on the right and the left, then you better go and make sure, maybe with the isRelated method, that you also have ARC, A related to C, in that order in the relation too. Okay? Because that's what it means to be transitive. You gotta make sure that for every pair where the middle parts match up, you also have the outside parts being related in that order. Okay? So that is probably the hardest one. Not too bad once you get the hang of it. So yeah, just get all these methods implemented. And then once you've got them implemented, it's then your time to test them. Okay, I've made all these tests, 6 of them, and they're just testing different kinds of relations. So like an injective function, these are the pairs, and it's making sure that, yeah, it's a function and it's also injective. So I really encourage you to like draw these out if you're having any trouble like understanding what these relations are saying. Just draw some dots and arrows. That's exactly what I did when I was making these tests. Okay. And then this one is making a function that is not injective. It's like the x² function. So it's not injective, but it is a function still. So it's testing that in addition to all your like isRelated to stuff, just making sure that that's all working. And then like a symmetric and transitive relation, a symmetric but not transitive relation, definitely draw them. A transitive but not symmetric relation, it's testing all those things, making sure that they're giving back the right answers. Yeah. So that is essentially all. Just get these tests to pass, and that is your lab. Not too bad, I hope. Yeah, I think that's everything. Get these tests to pass, and you are implementing a wonderful relations class with an underlying representation as sets of pairs of ints. Okay, so please yell at me if you have any questions about anything. I would be happy to answer them. And I think that's all I have for you. So good luck, and I will see you soon.